Hi YouTube. I've been really productive. I've been working on the planning. The overall planning for the project has been finished and I'm eager to enter development. I implemented a file picker, more specifically the one made by gallickgunner on GitHub. This is now used as the default edit widget for all resources. I aim to have a poor man's reflection system in my engine. This means that I want to get a list of all members in a class or struct, use this list to save/load/edit properties without needing manual property registration or to run a precompile step and injecting code like Unreal and Boost does. This is a challenge, but it's very possible using some templates and macro tricks. This is about to get technical. My original implementation was very straightforward. I have a class called property owner. It has a map of properties. I have a class property, which contains a name and some data of an unknown type. The reflected class would inherit from the property owner. Here is how that could look with a very basic settings class. But this syntax is kind of ugly. Let's wrap it in a macro. Now I had to find a way to add properties to the property map in the owner. My idea was to do this in the constructor, maybe like this. But to do that, the property had to know what owner was currently being constructed. I thought this could be done by setting a static variable in the owner constructor, like this. This code is relying on the order that the objects are constructed. My hope was the reflected type would be constructed first. Then the property owner constructor would be called, setting the static pointer to this, and then each property would call the add function from the static pointer. So what about templates? The property class has to use templates to support multiple data types. Implementing some nice operator overloads allow me to easily access the data too. But in order for this to work with the map in property owner, there also has to be a base class. We can move the name to the base class too. However, my solution has some flaws. Earlier, I mentioned that the order that objects are constructed is important. Turns out this depends on the compiler and can't be assumed. Also, if you copy a reflected class, the pointers in the property list would point to the original class, not the copied one. This truly was the solution for the poorest of men. But it was working. Now each property owner had a list of property pointers, and with this I could easily save, load, and edit. But I didn't want to settle for this. I wanted to tackle property memory offset. Currently we're storing the pointers to each property. In memory it looks like this. In our property map we then store a pointer to A, which happens to be at position 0 compared to the class, and a pointer to B, which happens to be at position 14 compared to the class. So all the pointers are basically just the pointer to the class, aka this, plus an offset. My thinking is that instead of storing pointers, I store the memory offset. That way, when a copy occurs, I can calculate the new property pointer by taking this and adding the offset. To do this, I changed the property map and added two conversion functions. This means that the property map is identical for all reflected class instances of the same type. For example, we have a settings class with a property called sensitivity. We then have two instances of the settings class, A and B. If you run this code and break at the end, you will see that the property map of A is identical to the property map of B. So why not initialize the map once and share the map between all instances? Shared property map. Currently, the map is a member of the property owner. Let's make it static. Now the same property map is shared between all property owners. But what if we have two classes with different properties that both inherit from property owner? This won't work. We could move the map to the reflected class and have a pure virtual that forces the user to implement the function, like so. You can see that the getMap is a pure virtual function that we override in the settings class, and that the settings class contains a static map. This works, but it will clutter the reflected class and requires the user to remember this quirk. I have another solution using some template magic. Currently, the inheritance looks like this: property owner to settings. We're adding a templatized middle step where the template parameter is the reflected class. This means that the static map in property owner will be unique for each class T. Now the inheritance looks like this: property owner base, property owner with settings as a template parameter, and then settings. This guarantees that one map exists for each class T, and it is now safe to share this map. But there are more issues. We still have to solve the construction order. Alright, the map is shared between owners, but the properties are still added once for each owner, overwriting the map with the same values. This is fine if we do it once or twice, but let's say I want all components in the game to also be property owners. That would mean that the maps would be overwritten quite a few times. Also, we still have the issue with construction order. For reference, the registration still looks like this. How can we make it so that the properties are only added once? And how can we guarantee that current is set? I decided to implement a static function that solves this. Let's take it step by step. First, we have the property owner base, which contains the static current pointer. Then we have a templatized property owner. In our example, T is settings. In the constructor of the property owner, we call reg. This static function is split into 5 steps. First, we have some code that guarantees that reg will only be called once. Then we create a local instance of T. In our example, T equals settings. Then we set the static pointer to the address of the local instance. Then we do a quick hack that allows us to manually call the constructor of our instance without making a copy. This is done by first running the destructor to make sure the memory is deinitialized, and then calling new, but providing the address for where we want the memory allocation to happen. And the last step is to reset the static pointer. And that's it. Now we have solved the construction order, and we have created a poor man's reflection system. This is what I intend to use for my game engine. Alright, that's it for this time.